Welcome to Sustainability Soundbites, presented by E and E Leader. Sulfur shortage is forcing phosphate production cuts. Sulfur has become one of the most consequential inputs in the U.S. fertilizer market, with record prices, disrupted global trade, and production curtailments colliding with rising crop demand for the nutrient itself. The pressure building in the U.S. fertilizer market is not coming only from nitrogen. Sulfur, a material most Americans associate with oil refining rather than agriculture, has moved rapidly toward the center of the fertilizer supply chain. Third-quarter molten sulfur contracts delivered to Tampa, Florida, settled at a record $705 per long ton, up from $655 in the second quarter, while U.S. set Gulf spot export prices reached $1,100 to $1,150 per metric ton in July, as buyers competed for supplies that would normally have come from the Middle East. The impact is already reaching farmers. As of the third full week of August, average U.S. retail prices stood at $916 per ton for diammonium phosphate, or DAP, and $959 per ton for monoammonium phosphate, or MAP, according to DTN, with DEEP 8% more expensive than a year earlier and MAP 6% higher. Researchers at the University of Illinois and Ohio State University warned this week that sulfur's surge could push phosphate costs higher still, noting that spot prices have exceeded $1,000 per ton, an increase of more than 130% since the beginning of 2026 and more than 300% since August 2025. For agricultural businesses, that makes sulfur more than another volatile commodity. It exposes an unusual dependency connecting oil refining, geopolitics, fertilizer manufacturing, and crop production. The shortage starts far upstream from the farm. What's driving that shortage is not a lack of sulfur in the earth. It is a shortage of sulfur available in the right form, location, and transportation network when fertilizer manufacturers need it. Modern U.S. sulfur production is overwhelmingly a byproduct industry, recovered primarily when refineries remove sulfur from petroleum and when natural gas processors clean sulfur compounds from gas. USGS data showed total domestic sulfur production fell from 8.32 million metric tons in 2024 to an estimated 8.1 million tons in 2025, with Louisiana and Texas accounting for roughly 54% of domestic output. Fertilizer demand cannot easily call additional supply into existence. It depends on how much sulfur-bearing oil and gas is being processed, where, and whether the recovered sulfur can economically reach fertilizer plants. Domestic elemental sulfur supplied about 63% of U.S. sulfur consumption in 2025, with imports supplying another 34%, and Canada representing 53% of those imports from 2021 through 2024. That domestic base has helped protect U.S. fertilizer producers, but it has not isolated them from a global shortage. The Strait of Hormuz changed the market. Conflict involving Iran restricted commercial shipping through the Strait of Hormuz in 2026, producing the sharpest disruption yet. Roughly half of global seaborne sulfur exports became trapped behind the strait after February 28th, and by July, Middle East flows were down by more than 1 million tons per month, pushing buyers that normally source sulfur there to compete for material elsewhere, including the U.S. Gulf Coast. China then added another constraint, halting standard-grade sulfuric acid exports beginning in May, after exports had already fallen 49% year-over-year to about 660,000 metric tons during the first 4 months of 2026. China's own elemental sulfur imports dropped sharply too, falling to approximately 2.26 million tons in the first half of 2026, down 57.7% from 5.34 million tons a year earlier, with June imports alone down 85% year-over-year, according to Shanghai Metals Market. Those disruptions have rearranged the global sulfur trade. Material produced along the U.S. Gulf Coast is now attracting buyers from North Africa and East Africa, creating competition for sulfur produced only a few hundred miles from major U.S. phosphate plants. Phosphate producers are already cutting production. Those pressures are already visible in fertilizer manufacturing. Sulfur is converted into sulfuric acid, used to process phosphate rock into phosphoric acid, the foundation for widely used fertilizers including DAP and MAP. University of Illinois economists estimate that producing 1 ton of DAP requires roughly 1.5 to 2 tons of phosphate rock, zero point 0.4 ton of sulfur, and zero point 0.2 ton of ammonia, making a several $100 sulfur price increase difficult for manufacturers to absorb. Mosaic, one of the world's largest phosphate producers, has already begun reducing output, reporting in August that it had completely idled its Faustina, Louisiana facility, while Bartow, Florida operated at roughly 40% of its targeted annual rate, with other Central Florida plants running in the low to mid 70% range. Mosaic says approximately 80% of the sulfur used by its U.S. operations comes from Gulf Coast refineries, and has estimated that global phosphate production could fall as much as 30 million metric tons below last year's level if constraints persist, a concentration risk that echoes how few companies actually control U.S. crop nutrient production. The result is a feedback loop. Higher sulfur prices make phosphate more expensive to produce, producers cut output rather than sell at uneconomic margins, and lower phosphate production tightens fertilizer availability further. Farmers are also needing more sulfur. U.S. agriculture is absorbing this shock at an awkward moment because sulfur has simultaneously become more important as a crop nutrient. Farms historically received substantial sulfur through atmospheric deposition, as sulfur dioxide from coal-fired power plants and industrial facilities ultimately settled onto farmland as sulfate. Air quality improvements have sharply reduced that source. Iowa State University agronomists report that atmospheric sulfur deposition in Iowa has fallen to almost zero, and estimate that plant-available sulfur in soils has declined 34% to 86% over the past 2 decades, making deficiency in corn and alfalfa increasingly common. Purdue Extension's 2025 field program found that 87% of cornfields sampled at mid-season were below its sulfur threshold, though tissue tests alone do not establish that every field would economically respond to added fertilizer. And higher crop productivity also means more nutrients leave fields with each harvest. Scientists caution against assuming every farm should simply apply more sulfur, however. University of Minnesota Extension specialist Daniel Kaiser has found that high nitrogen rates do not themselves create sulfur demand. Instead, adequate nitrogen can expose an existing deficiency that was previously masked because nitrogen was the crop's primary limiting nutrient, and a non-responsive site will not become responsive just because more nitrogen is applied. Kaiser's research found sulfurphosphation increased corn yields by roughly 4% at responsive sites when nitrogen was adequate, but growers should manage sulfur by soil and crop response rather than tying it automatically to nitrogen rates. His work also shows sulfate does not always disappear quickly from soil. 10 pounds of sulfate sulfur per acre, applied for 4 years, provided enough carryover at some sites to meet corn needs for at least 2 additional years, a distinction that matters more when prices are unusually high. The risk is moving into 2027 fertilizer decisions. None of this means the country will run out of sulfur. What matters is whether enough can reach phosphate plants at prices that let those facilities keep producing economically, a question growing more pressing as farmers plan 2027 purchases against tariff and trade uncertainty already reshaping agricultural input costs more broadly. Illinois DAP prices reached $912.22 per ton in early August, 7% higher than a year earlier and 24% above August 2024, with national retail data putting DAP at $16 and MAP at $159. The sulfur shock also highlights a broader procurement vulnerability, echoing how other resource dependencies are reshaping agricultural supply chains. Sulfur supply is determined partly by decisions in industries with little connection to farming. Refinery rates, gas processing, smelting, trade restrictions, and shipping through the Strait of Hormuz can all change the cost and availability of an agricultural input, while decades of lower atmospheric deposition have shifted more responsibility for crop sulfur nutrition onto growers. Those two trends are converging, and sulfur is becoming something it rarely needed to be in the past, an input worth monitoring independently, not simply a component buried inside the price of phosphate fertilizer. Interested in a Soundbite sponsorship? Contact our team to learn more. Thank you for listening.